Hello, my friends from everywhere in the world. Welcome to another DevNation Tech Talk. This week we had Red Hat Summit, and as usual, we had a lot of great sessions, a lot of great demos, and this year's Red Hat Summit's keynote demo was a super amazing application. We were using Kafka, we were using Serverless, and we had this super cool Battleship game. And today's guest is one of the stars of the Red Hat Summit keynote. So let me introduce you to Evan Shortis. Evan, welcome, and thank you very much for joining us.
Hey, Edson. Nice to be here.
Yeah, awesome. And well, great job on the keynote. And how was it exciting to be part of this live demo?
Yeah, it was pretty awesome. This year I was more involved than I've ever been, actually, because I did get involved in previous years doing some front-end work, but this year was lots of back-end engineering with the Kafka and Node.js and Quarkus side of things. So it was pretty cool. It was a good experience.
Oh yeah, and I was super excited when you accepted our invitation because then you'll be able to share a bit of what you did in the keynote demo, so people will know more about the technologies. So yes, we're expecting a lot of great stuff. And by the way, where are you streaming from today?
Oh yeah, good question. I'm in Waterford, Ireland, so the south coast of Ireland.
Okay, so yeah, we have some 1,000 kilometers apart from each other because today, live from Cary, North Carolina and Waterford, Ireland, welcome to DevNation. Evan, the stage is yours.
Okay, let's have some fun, or at least I hope so. Right, I'll just do some slides quickly to get this started and make sure everyone's, we're all on an even playing field in terms of knowledge going in, I hope. So let's do that now. And I'll keep this really quick so we can get onto the fun stuff as soon as possible. So today's session, as Edson mentioned, it's about Red Hat OpenShift Streams for Apache Kafka, a new managed product we launched, or a cloud offering we launched.
And Evan, your slides are not showing yet.
Oh, are they not? I'm in full screen mode. Let me. Can you see my screen at all?
I'm going to put your screen here, but I'm still seeing the studio.
Oh. The joys of live. Will I stop sharing and reshare? Maybe that'll fix it. Because it worked earlier when we tested. Try again. Entire screen. Allow.
Okay, all right. I can see the console again. All right. Now we can see the slides.
Okay, I'll go full screen again and hopefully it works. How does that look?
Perfect.
Awesome. All right. So, as I was saying, this session today is about Red Hat OpenShift Streams for Apache Kafka. And I'm Evan Shortis, a technical marketing manager with Red Hat. And what we'll talk about today in terms of, in the order, we'll do a quick overview of Apache Kafka. I'll keep that real quick because I'm guessing some of you already are going to know that stuff. Apache Kafka use cases and examples. In other words, what's it actually useful for? Then we'll dive into the Red Hat OpenShift Streams for Apache Kafka introduction. So I'll go over the service and show you how to get started and use it. And then I'll show you how we can use OpenShift Streams with a Quarkus application, because I know lots of you guys out there love to write applications using Quarkus and Java. So we'll do that too. And I might even get on to showing OpenShift Serverless, which is what we did at Summit, and do a little deeper dive on that if we have enough time. So really quickly, what is Apache Kafka? I decided this piece to just show what they say on their own website rather than trying to make something up. And the way they describe it is an open source distributed event streaming platform used by thousands of companies for high performance data pipeline, streaming analytics, data integration, and mission critical applications. It's really a huge distributed log store with tons of messages flowing through it, and it can persist them for as long or as little as you need. And it has a few different pieces. I'm not going to deep dive on all these, but you have an admin API to manage Kafka itself. So that's your brokers and the topics and the data in them. You have the producer API to publish, consumer to consume from topics. Streams API, which is a really powerful way to implement streaming pipelines that aggregate data, perform map reduce type operations, and all that kind of really cool stuff. And then you have the Connect API to import and export data easily into your Kafka topics. So they're effectively connectors that you can easily sync up to other data feeds, so your database and other services. And in terms of the architecture, this is a really, really high level picture. So I appreciate that it might be oversimplified almost, but effectively you generally have producers and they're going to write data using that producer API we just mentioned. And you typically will run 3 or more brokers for Kafka because we want high availability. So if 2 brokers go down, you still have 1 up and they all replicate the data. So you should have no data loss. And then you write data into topics. And generally, you'll have multiple partitions within a topic. And those partitions allow you to highly parallelize your data. So the more partitions you have in theory, the more consumers could be reading and processing those data streams in real time. So that's a really high level view. And if you were to visualize that here, you can see, again, this is a simplification, but you've producers and they're all writing data and that data will get pushed into different partitions. And then you can have 1 or more consumers for each partition to rapidly consume that data and do whatever real-time analytics or data processing you need to do. So it can scale out hugely. And I'm in this diagram only showing 3 partitions, but sometimes you can have hundreds of partitions, for example. That's not uncommon. And at Summit this year, actually, for some of the stuff we did have 100 partitions. So you can imagine that it scales up very well. And then in terms of the event structure or the data structure you write to Kafka, it generally is 3 pieces. You're going to have a key, which is typically unique identifier. It could be like an email address or a unique key, like an ID row from a database. Then, of course, you have the value that you're writing, and you have a timestamp. On the right here, I've done that as JSON. Kafka actually has a binary protocol, but I think most of us understand what JSON looks like, and that gives you a good idea of how you might represent that data if you were to do it yourself. So that was really quick, an intro to Kafka. And then let's look at some use cases. So like I said, you for real-time applications. So digital experiences, you need real-time immediate access to information. So you need to process information quickly for that. So that's one example. Then you have microservices applications. We're all building smaller applications these days that are loosely coupled. And using Kafka is a great way to do that because it's fault tolerant, right? You can take down a service and roll up a new one. And if each service is pushing data into Kafka, when the service goes down, the data will be there when it comes back up. So when the service comes up, it can pull data out of Kafka and resume processing it. So it's nice to have that loose coupling between your services. It's great for streaming, ETL and CDC type scenarios. So if you have old applications that are driven by batch processing, you can change those to become real time. For example, a database, you might be doing batch operations to read from that and update things. Instead, you can use something such as the upstream Debezium project with Kafka and capture changes in real time from your database log and create event-driven real-time applications from that instead of periodically querying and doing batch updates. And then, of course, real-time analytics. So you're ingesting data from multiple sources to get better insights and for collecting data just from different devices, edge devices. And tons of companies are using this. For example, Shopify had a great article recently where they talked about how they used Kafka and Debezium for their real-time metrics. So instead of using old school batch processing like they were before, they moved to using change data capture from their database and had real-time insights for their analytics for their users. So that's a fantastic upgrade or benefit to their users. Then Uber, of course, they're huge. Everyone knows who Uber are. They're doing things with Kafka as well. They have tons of blog posts on what they do with Kafka. Just one here is they were building a reliable retry logic because they have huge distributed systems and they use Kafka to accomplish that. And then, of course, Red Hat. We work with tons of customers in both managed and cloud scenarios where we help them to build out infrastructure using our AMQ Streams product. And now we have OpenShift Streams for Apache Kafka. So we're doing things with banks and insurance industry in this space. And if you were at Summit yesterday, you might have had fun and seen a real practical example of this in action. So at Summit, we built a kind of Battleship style game. And if you think about a game like Battleship, it has a lot of events. So it's a board tabletop game, 2 players face off against each other. But the events are you position your ships, for example, that's an event. Then both players say, yeah, I'm ready, another event. And then they send shots to each other's boards, right? So you're trying to sink the other person's ships. And each of those is an event. And then if you hit, miss, or sink, that's another event type. And then finally a winner is declared. And we use Kafka to capture all of those events when you were playing the game at Summit yesterday. So you can see here, when you first joined the game, that's an event. And then when you position your ships in the UI, we captured that too. And even when you took all those shots, you can see the red pegs here are hits and the white's a miss. We captured all those events. And it might have looked something like this. We were using JSON. So we were sending all those JSON payloads to Kafka, and they contained coordinates of ship positions and who the player was who was making those shots. And eventually, we used that to generate a few different things. But one of them was this real-time leaderboard that you saw when Burr was doing the presentation. And you could see that we had sinks, hits, misses, games, and this was also powered by other Red Hat technology as well, like OpenShift and Infinispan. And we even took it a step further, where we did this really cool thing, if you stayed around till the very end, where we aggregated all those events using the Apache Kafka Streams API. So we aggregated all those events into one complete record. And we were able to then do this cool replay. So we had an API where we could query all those events in one large aggregated form for the winners of the games. We didn't query everyone's because that would have been a few thousand, but we brought back the top 10 or top 100, I think. And we were able to see all the turns in the payload here and replay them in real time on the screen in front of you. So you can do very powerful stuff with Apache Kafka. And this game was just one example. But let's actually talk about Red Hat OpenShift Streams for Apache Kafka itself and get to having some fun with a live demo here. Before I go any further, I should be careful here with names. We sometimes refer to the product as OpenShift Streams as well. So the long name is Red Hat OpenShift Streams for Apache Kafka, but we often just say OpenShift Streams to keep it brief. But you'll also hear Managed Kafka or just Kafka as well. So why would you want to choose Red Hat OpenShift Streams for Apache Kafka? The main answer is reducing complexity. If you look at this diagram here, there's a ton of moving pieces. If you're managing Kafka, you have to deal with Kafka itself and then Zookeeper. If you're running it on Kubernetes, you're probably using Strimzy, which is a upstream project that Red Hat's involved in, and it's behind our AMQ Streams product, which is used for managing Kafka on Kubernetes and OpenShift. And then, of course, you have all these VMs and infrastructure underneath. And that's a lot of stuff to be managing. So you would probably rather focus on managing your own applications that are accomplishing business value and leave someone else take care of managing Kafka, or at least lots of people would. It's a specialized skill set, and it's a lot of work to manage all these moving pieces. And that's where OpenShift Streams comes in. So by using OpenShift Streams, you are able to build your applications faster because you can focus on them while Red Hat is focused on managing the Kafka pieces for you. And it also unifies the experience across clouds, is what we like to say, because we can deploy it in various cloud vendors and regions for you. And it's all automated. We can automate it, and we have a support team watching all of those clusters 24/7 around the globe. And then, of course, Red Hat's involved in various projects and has various technology that's complementary to Kafka. So you've Debezium, which is great for capturing changes in your database. You've Camel for building integrations. You've Quarkus, which has fantastic integration with Kafka as well. So you have this whole ecosystem behind it. And then because it's hosted and managed, like I said, Red Hat owns the SLA. So we make sure everything stays running smoothly for you. We do upgrades, zero downtime upgrades, and SLA the service. And our support team are around the globe. So you get 24/7 coverage every day of the year. So there's a lot of value there in terms of not having to take care of that yourself and focusing on just building your own applications on top of it. And like I said, we've been working with customers with Kafka for a while. We have these public references. And I mentioned the projects and ecosystem we have to deliver solutions on top of Kafka. So how can you get started with this yourself? It's pretty easy, and I'm going to show you all that in a minute. But basically, we have a flow where you can go to Red Hat Developer. You can sign up to cloud.redhat.com. You then get access to Kafka itself. You can create clusters, and then you can deploy and develop your applications that use those Kafka instances that we're running for you. So the general flow is sign up, then use our UI or our CLI, which you'll see in a moment, to create your Kafka instances. Then you can connect it to your OpenShift or Kubernetes or applications running anywhere, really. But of course, OpenShift is a great way to do it and a great place to run your applications. And then you can do this awesome service binding that you'll see as well, where we make it incredibly easy for you to inject the connection details for your Kafka instances into your applications. So you don't have to be dealing with managing credentials and bootstrap URLs and all that stuff. We make that a lot easier. So to get access, you can just go, oh my God, sorry, a phone was ringing. Okay. Sorry about that, Edson. Give me one moment.
That's how you know it's live, because things are happening in the real world.
Yep, sorry about that. I forgot to turn off the house phone. My other phones are off, but the house phone wasn't off. Okay, sorry. Now, so getting access. Like I said, you can go to Red Hat developers or developers.redhat.com, and we have a page for Red Hat OpenShift Streams. You can create an instance there. You can see that red Create Kafka Instance button. That will allow you to get access. And then, of course, we'd like you to run your applications on OpenShift that connect to those Kafka instances. And there you can use, again, developers.redhat.com to get access to an OpenShift sandbox environment, which I think you get it for almost a month or at least 2 weeks to run your applications. And the Kafka instance itself will last for 48 hours at the moment. So it's very easy. And then we have quick starts as well. So once you get access to the service, we want to make it easy for you to learn how to use it. And we have these contextualized tutorials that you'll see me use in a moment, where they effectively overlay the UI and allow you to follow along, basically. So yeah, let's get started. So what I'm going to do here is go over to cloud.redhat.com. So this is where if you go to developers.redhat.com, you'll be redirected here if you have an account. If you don't, you'll just have to sign up, and then you'll be able to get to this screen. And you can see here we're in the Application Services UI. And we want to go to Try OpenShift Streams for Apache Kafka. And if my internet hurries up, it'll load. And there we go. So this is the UI for OpenShift Streams for Apache Kafka. And you see here on the left, we have our navigation. So we have our Kafka instances, we can manage service accounts, and we have resources. And that's those quick starts I mentioned. And you can also see I already have created a Kafka instance here. So if I click on that, we can see some details about it. So we can see the cloud provider where it's running, the region, the ID, and the fact that I own it. So we have all this information available to us. And if I go to the connection tab here, I have access to information on how to connect to my instance. So I have a Bootstrap server, I have service accounts, and I have the authentication details. So that's SASL OAuth bearer, and we'll get back to that in a moment. So let me close that and go to the resources section. So we have this getting started guide, and I'm going to show you a little bit of this. So the first thing they ask you to do in this guide is create an instance. Now, I've already done that. As you could see, I had one, the DevNation one that I created earlier. But I haven't done any of the other steps here. So we need to create a service account to connect to Kafka. And we also need, if you go down to the third step, actually, let me just go ahead and do this now, create the service account. So it's telling me create a service account. So to do that, it tells me to go to the Kafka instances page. So I'll click there. And you can see the tutorial is overlaid in the UI. So I can follow it along in my own time, and it's always there, so I don't get lost. So I can click on my DevNation Kafka instance, select connection, and you see the Bootstrap server as I saw earlier. And I can click on this Create Service Account button. And all I have to do is click here and give it a name. So I'll just give it my name. And I could fill in the description. I'm not going to bother. I'm just going to click Create. And this generated a service account just like that. Now, it is important to note that these credentials are only shown at this point in time. After I close this window, I lose them. So I need to take note of those credentials. So let me go here to my notes. I'll copy the client ID and the client secret. I'll put them here in my notes. And obviously I wouldn't normally share this with people, but we're all friends here today, so I won't keep it secret. So I'll close that. And I should also copy the Bootstrap server URL just here for later. And I'll copy this SASL OAuth bearer endpoint as well. I'll put it there. So we have those pieces of information for later when I move on and actually show you how to use this with a Quarkus application. But yeah, so we've created a service account. So I'll scroll down here and click next and confirm I'm ready to go ahead to the next step. And here it's telling us now to create a topic. So like I did in the overview earlier, I explained you use Kafka topics to store events. So we'll want to create a topic. So I'll close this overlay here, and it tells me here to create a topic. I can click on my instance, and it'll load up the topic UI. And I get a nice button here. It's really easy to follow this wizard in the UI to create a topic. And for the name, I'll put in prices, because the sample app we're using, I'll show you in a moment, uses a prices topic to store data. So I'll go ahead and click next. And here we can configure partitions. So like I mentioned earlier in the introduction, partitions are really important in your Kafka applications. One partition means you can't really parallelize your application, right? It's only one partition, so only one consumer can really read and process records at a given time. So we could bump that number up to 100, for example, if we wanted to really make this application scale. But for the sake of this example, actually, we don't need to. It's just a very basic application. So I'll go ahead and stick with one partition. Then, of course, Kafka has a message retention. So I'll leave that at the default, but we could change it if we just wanted it to be a day, or we could even change it to be unlimited. So Kafka never purges old records. It just keeps them around forever. But we'll go with that. Retention time is a week, and we'll hold records for forever, or at least we'll hold them for a week. So we could produce 1 million records in a week, and they'll stay there. So I'll go ahead and click next. And then the replicas. So this is this comes back to the brokers piece I mentioned earlier. So we want to make sure that our data is replicated across 3 brokers. So that way, if even 2 of them go down, we still have 1. So our application stays running. So we have high availability. And we deploy those across multiple availability zones in a given cloud region. So you're insulated from outages. So you can see at least 2 will always be in sync. So I'll click finish. And that's it. I now have a prices topic. And it was that easy to do. So I'll keep scrolling down here. Click next. And it asks me, is my Kafka topic listed in the table? I say yes. And that's it. It's that easy to get up and running with this. So we have created a Kafka broker. We've created a service account, so my applications or my tools can talk to it. And we're ready to try hook this up to an actual application. So I'll click close on this because I'm finished. And I'll go back to the resources. And you can see our second resource here is using Quarkus applications with Kafka instances. So let's click that. So it's 4 steps. So the first is to import Quarkus sample code. I already have done that, so it's telling me to git clone a repo locally. Like I said, I've done that, so I'll go ahead, move on to the next step. And here it's telling me to configure it to connect to my Kafka instance. So it explains here to enable it to connect to it, I need to use the SASL OAuth bearer token endpoint. And I can configure this in my application properties file. So let's go ahead and take a look at the code here. So if we take a look at this application, you can see I have my application properties here, and I have a dev profile here in my properties, and it takes a Bootstrap server from the environment variables. it takes the client ID, client secret, and the OAuth token endpoint URI. So we're going to need to set those. And if I go back to the tutorial, it's probably going to tell me that. So it's explaining that Quarkus is using micro-profile reactive messaging, and it actually does explain those variables here. So let's go ahead and set them. So the first thing I need to do is set the Bootstrap server. So I'll go to my terminal here and go into the correct directory and set the variable. So Bootstrap server, that's here in my notes. So let's copy that, set it here. Next thing I need to do is set the client ID. So I'll do that now. In my terminal, set client ID equal to the ID here. Set the client secret. And then finally, I need to set that OAuth token endpoint. So I go back to my notes and copy that here. Okay, so I have those variables set, and all I need to do now really is start the application. So let's read down on how I can do that. So I've already reviewed the application properties, so I'm ready to go ahead and click yes. Okay. So it's telling me here that I need to go ahead and create a topic, and I need to name it prices, which I've already done. So we'll skip past here. I do have a prices topic, so I'll click next. And now we're getting to the fun stuff where we run this application and see it working. So you can see here it explains that it's an application that just generates some random numbers and puts them in a Kafka topic. So it's saying it generates a number between 0 and 100 and produces it to the Kafka topic, and it'll render it in a web UI. So let's give that a go. So the command to start it up here, if you're familiar with Quarkus, you probably already know this, but it's the Quarkus dev command. So let's go ahead and do that now. And hopefully it doesn't take too long. I think I should have dependencies locally. Yeah, it's starting up. There we go. So it should be running on 8080, I think. So I'll go localhost 8080. And there we go. My Quarkus app is running. So that's good. And if we look here, you can see the Kafka producer looks like it's connected. So if I go to the prices endpoint in the application, it's saying no price at the moment, but it should start generating prices shortly. Yeah, there we go. Okay, awesome. So it's telling me the last generated price was 22 euros and 88 cents, and so on and so forth. It'll just keep generating prices and displaying them in this application. So if we go here to the logs here, we can see that it's connected and it's producing. So that's awesome. So our application is up and running. So let's go back to the quick starts, and it's telling me now that if it's up and running, I verify the last price is updated, which I did. I can go ahead and click next. There we go. That was it. I set up my first Quarkus application and have it generating information, and it's going through this managed Kafka service. Now, there's other stuff here, like we can show you how to use Kafkacat with it. So let's just quickly do that. So I already have Kafkacat installed. So let's look at it and get it connecting to our instance. So similarly, this is going to use environment variables as well. So I've already set some environment variables here, so I can skip this step. And now we have a command here telling us how to read from the Kafka topic. So it's Kafkacat-T, which is going to be the topic. So I'll go ahead and follow that. Just have to wait for Quarkus to finish here. Actually, let me clean up my terminal and make it look a bit cleaner here. There we go. So I'll do Kafkacat-topic, and the topic is going to be prices. And then the Bootstrap server URL, well, we know what that's going to be. That's going to be what I set it to earlier in the variable Bootstrap server. And then the security protocol is SASL SSL here. So I'll paste that. And then the mechanism is plain. So I'll paste that too. And then the username is going to be the client ID I pasted earlier. So client ID. Then finally, the password is the client secret. And then the last thing I'm going to do is pass it the -c flag, which means I want to consume. So I want to consume the prices. And if I recall correctly, it shows up kind of strangely, because it's like using some binary protocol here. But you can see that it has reached the end of the topic prices, and I've 21 generated prices in that right now. So it's really easy, as you can see, to connect to your topics and read data and produce them using Quarkus. But so far, everything has been local. So that's pretty nice, but we'd like to run it on OpenShift or on some online or on some cloud platform, I guess. And OpenShift obviously is what I'm going to go with. So I have an OpenShift cluster here. And what I'd like to do is run my Quarkus application. So I have already actually built it into a container image. So if I go to container image here, and I have it here in key.io. So it's this URL here. So it's key.io. And then I say / Evan Shortus, Rosac price example. And there should be a Quarkus icon. Yeah, there we go. Because it's a Quarkus application. I want to list it as such. And then we can give it an application name. So I'll call it prices example. Actually, I won't give it an application name. I'll just give it a regular name. And make it a deployment. And we do want to expose a route to the application, so I'll leave that box checked so we can verify it's actually working like I did on my local host. So now I'll go ahead and click create. But you might be asking yourself, don't I have to tell it how to connect to the managed Kafka instance? And yeah, you're right. This actually isn't going to work yet because there's another step I got to do. So let me show you. We have the managed services CLI. So if I take a look at that here, you can see it has various commands available to me, like cluster or completion. If I want to enable auto completion, I can manage my Kafka instances. I can manage my service accounts, log in, log out, all that kind of stuff, right? So I'm already logged in, I think, and we can easily check that if I just do the Kafka list command, if I type it correctly. So yeah, awesome. So you can see here that I have one Kafka instance, and it's the one that you saw called DevNation. And we know it's ready because we just saw it working on my Kafka application. So that's great. We can also take a look at the service accounts. You saw me create that earlier. That was the client ID and secret piece, and you can see it listed here. My font is a little big, so the formatting is funny, but I think you get the idea, right? It's my service account that I named Evan, and you can see the name here, and you can see its ID. So that's working too. We can even take a look at Kafka topics. So if I do Kafka topic list, and I spell list correctly this time. So I forgot to do one thing. So I need to pass it an ID, but passing an ID each time for the Kafka instance you want to use is kind of frustrating, as you can imagine, if you're going to be using the same instance multiple times. So we have this nice ROAS Kafka use command. And you can see here, I can use the arrows to select the Kafka instance I want to use. I only have one, which is the DevNation. So I'll select that. And now if I do the rows Kafka topic list, it should return the list. There we go. So you can see the prices topic now. And you can see it's configured with that really long retention time like we did earlier. And the retention size, like I did as well in the UI, is unlimited. So that's fantastic that that's working. But like I said, I want to connect my Kafka instance to my OpenShift app, or my application running on OpenShift, as you can see here. And the reason is, if we take a look at the logs here at this application that I deployed, if the logs load, that is. Let's try view the raw logs. There we go. Okay, if we click that, we can see it here. So you can see here, it says a connection could not be established because it's trying to connect to localhost, which is not going to work. I'm not running Kafka on this OpenShift instance, and I'm not running it on my own machine. So this Quarkus app on OpenShift right now, it doesn't have any Kafka connection. It wasn't able to establish one. So let's help it do that. And that's where this ROAS cluster command comes in. So you see, if I look at the help output, I can use cluster connect. That's what I'm looking for here. There's also cluster bind to bind it directly to my application. But let's look at the cluster connect command. Now, to do that, I need an OCM token. So let's just get it started, though. So I'll do ROAS cluster connect. Actually, first, I need to make sure I'm logged into OpenShift. So let's check I'm on the right OpenShift project using the OC CLI. And I am. I'm on the dev project here, which matches what I'm on in the UI, which is perfect. So I am going to do the ROAS cluster connect. And it gives me prompts so I can follow along. So it's saying the Apache Kafka instance I'm using is the DevNation one, and I'm connecting it into my namespace, which is eShortest and it's going to generate a new service account, and it's going to create a secret to hold that on my OpenShift cluster, which sounds great. So I'll go ahead. Oops, I forgot to type yes. So I'll go ahead. Now, to do this, we need to provide a token for the operator. So this is all powered by an operator on OpenShift to make it easy to do all this binding, and it needs a token. So it can effectively communicate with my cloud.redhat.com account. So let me go ahead and get that token. So I go to this URL and copy the token. Paste the token, press enter, and there we go. So it connected it created a connection between my OpenShift cluster and my managed Kafka. So it even tells me here, or it even shows me how I can use this kubectl apply command with some YAML to bind the Kafka instance to my Quarkus application. But before I take a look at that, I'm going to go back to my OpenShift cluster. Oh, let's try that again. Let's refresh. Oh, I think I know what's going on. So I think what's going on here is my UI in my cluster is not ready for this yet. So what I'm going to do instead, as happens with live demos, is I'm going to try something else. And let's see how that goes. So I will go ahead and delete that service account, because there's a limit on how many service accounts we can have at the moment with this evaluation account I'm using. So I'll go ahead and do service account delete, because I want to create a new one to retry this using a different command. Yeah, I'll go ahead and delete that service account. I'll just delete the secret here too, to make sure we don't get any conflicts when I try and do this again. So that's fine, no big deal. Nothing to worry about there. Instead, what I'm going to do is use the ROAS cluster command again, but I'm going to use the bind one to bind it directly to the Quarkus application. So let's try that. So you can see it's using the default namespace, and it has found my prices example application. So that is the one I want to bind it to. I'll select yes. And that bind should have worked. So let's see. The application should be updating, unless I have an old service binding hanging around, which I didn't delete. I love demos. So this is actually something I was going to show anyway, by the way, but we can run this OC get service binding command to see that the service binding was created. And you can see here that it was, right? So we have a DevNation, and it gives it a random ID, and it's only a few seconds old. So the service binding was created. And if we want, we can even describe it. So let's describe that and take a look at what's inside. Might take a moment to load. Oh, I never said service binding. This is how you know this is live, all these little typos. But here we go. So you can see the service binding. You can see all the information, the YAML, or pretty printed YAML here. So if I scroll down and take a look, you can see it's binding it as files. So that means it's mounting the secrets that I need to use as files into my pod. But it's giving me an error saying this cloud services account was not found. So I know why that is, because I deleted it. So bear with me one moment, and we'll get that working. Because I undid my cluster connect, which was a mistake. And I need to delete the old Kafka connection too, to get this working. So not to worry, we'll get there. Okay, and we'll delete the service binding too. We'll do it one more time, and we'll get it working. So let's go ahead and do that. Assuming I can spell service binding properly. There we go. Awesome. So it'll take a second to delete that. And then what I'm going to do is I'll just run the commands again, and it'll be fine. And if not, we'll move on and show something cooler. So there we go. We'll do the cluster connect again to make sure that secret is there this time. I'll get that token. This is the joy of live demos. Paste in my token. There we go. Okay, so we got our secret that I shouldn't have deleted last time. And we'll do the cluster bind again. And we'll pick the same application. And we do want to continue. I'll go back to OpenShift. And there we go. So this time, it was very brief, but there was a rollout there in the application. And if we go to the endpoint for it this time, and we go to prices.html, the timer should start running, and we should start seeing prices, assuming it worked. There we go. We got prices. Awesome. So let's take a look at the logs. And we should see that it has connected to the Kafka broker this time. If it loads. Do I have to go to the raw menu again? I do. All right. And there we go. Right. So we can see that it's connected to my if I can find it in the logs. Yeah, down here at the bottom, you can see it's connected to my DevNation cluster in this broker field here. So this application is now connected to my OpenShift Streams instance that's managed by Red Hat from my OpenShift cluster. So it's very easy if you don't accidentally delete stuff like I just did. And it's that easy. You can build your Quarkus app, deploy it, and then use this CLI to create that link, that service binding. And one thing I didn't show you was, well, I did when I deleted it, but let me show you now again. The Kafka connection. So there was two resources created on this cluster. We created the Kafka connection, and we created the service binding that uses it. So those two pieces of information are being used by my Quarkus app to get the information it needs, which is the broker URL and the service account information to connect to my cluster, my Kafka cluster managed by Red Hat. So it's really easy to get up and running with this, as you can see. Now, Edson, I'm not sure. Are we doing okay for time here? I think we are. Yeah. So there's one more thing I was thinking of showing while we have the time. So at Summit yesterday, we got even fancier, right? We used Quarkus again and Node.js, and we even used Knative. So we were using the serverless framework to process payloads, which is really cool. So you can see here I'm running on a newer version of OpenShift that shows this nice little OpenShift Streams icon here in the topology view. So that's why I got tripped up on my last cluster. It doesn't show this just yet. But here we have the Summit demo that you all saw. And if we want, I can go ahead and show you how it works. So I'll go over to my OpenShift Streams cluster. This is a different OpenShift Streams account, or cloud.redhat.com account, and different OpenShift Streams instance to what I showed off just a few moments ago. You can see it's my Summit instance. And if I click here to take a look at it, you can see I have the shots topic, which I displayed during Summit demo if you were watching live. And that has 3 partitions. And we're using it to process shots that people created using that Battleship game. And what's interesting about this application is because it's using serverless, it's scaled to 0. So you can see here that it says auto scale to 0. And you can see I have a node app here that's pointing to my Summit Kafka instance. And that node app also has a binding on it. So if we take a look here at the route for the application, if I open it and I go to the bonus endpoint and I can do send a single shot, and we get back some JSON here that tells us what the shot information was. It's randomly generated for this example, but when people are playing the game, they're real shots, as you can imagine. So I'll go ahead and take a look now at my topology view, and we can see, if I zoom out, that the Quarkus pod has spun up. And if I take a look at the logs for the correct pod, it spins up multiple pods. So that's not the right pod there. This is the one. It processes all those payloads. So what we should see is the username here, which is Gravefly. We should see that in the logs here, and you can see it. It's been processed. So it created a message in my Kafka broker, and it processed it for this player called Gravefly, which is a very strange username. But yeah, so you can see that not only is it easy to connect this to regular Quarkus applications, but you can even connect it to serverless applications that are developed using Quarkus. And if we want to even take a look at the source code for that very briefly, I have it open here in my editor. It makes getting started ridiculously easy. So we have a function Java class here, and it's using the Quarkus func library. And all we have to do here, I have a thread.sleep in here to make it actually slower so we can spin up more pods. If I didn't put that in, only one pod would spin up for thousands or potentially hundreds of messages. So that's why that's there. But you can see here, it just takes an input, and I have an input class, and we're just using standard Java Jackson here to process the incoming JSON and deserialize it into a Java class. We're reading all the properties from it, which that's coming from that Node.js pod via Kafka. And then for the output, I'm just calculating the score. So I take the incoming integer of shots and multiply it by 5. And then this app will return that to another Kafka topic and process it for the game you saw yesterday. So yeah, I think, Edson, I think that's it for me. I don't want to go any further. I think that's enough information overload maybe already. But we would love people to go to Red Hat developers here to this page for Red Hat OpenShift Streams for Apache Kafka and sign up and try it for themselves. You get a free instance. You don't need to pay anything, no credit card required. And if you need an OpenShift instance to try it with, you can just go again to Red Hat developers to the developer sandbox and get an OpenShift environment and try this yourself as well. And it's all free of charge, no credit card necessary. So we definitely want people to sign up, try it, and have fun with it for sure. So how are we looking, Edson? Do we have any questions?
Yes, we do. And thank you for the presentation, Evan. And let me try to find the questions here. So the first one regarding the Red Hat OpenShift Streams, the managed Kafka thing. So are we limited regarding resources, number of topics?
I can't hear you, Edson, if you're talking.
Sorry,
did you hear me? Or is my stream messed up?
I think mine is working. Yeah. Can you hear me?
I can't. Will I refresh? How about that? Maybe give me a thumbs up. I can see you.
Okay, I can see you.
But I can't hear you.
Let me restart. Well, people on the stream, if you can hear me.
Sound is working, someone says, which means I probably have an issue on my end. If
Yes, I can hear you.
will I refresh? Would you want to give me a thumbs up for a refresh? Will that break anything?
You can refresh.
Stop sharing my screen, maybe.
Okay. Well, that's the magic of doing live things. So I think Evan is
All right.
back. Okay, so now you can hear me?
I can hear you now. Yes. Awesome.
Okay. Perfect.
I'm not sure what happened there.
Yeah, so we have the question here. So regarding our managed Kafka, the Red Hat OpenShift Streams, are we limited regarding resources, number of topics, something else?
Yes, so there are some limits, and I believe they're on that developer page. So they're pretty generous, I think, though. Like you get, for example, you get 3 replicas, of course, and they're in multiple availability zones, right? So it's HA. The number of service accounts you get, right? So you only get 1 service account, or sorry, 2 service accounts. So you can't, generate tons of users. And also we limit you to 1 Kafka instance at the moment on the free trial tier. So it is limited in terms of how many the instances you can create and how many, of those Sazzle accounts you can connect to it. But it's pretty generous as far as the free tier goes, I think. Mm-hmm. And I think the other limit worth mentioning is ingress and egress. We limit that to, I think, 2 megabytes in, 2 out. And there are some limits on number of partitions, but I think that's pretty high. Like I mentioned, lots of people create hundreds of partitions, and we do support that.
Awesome. So the magic word here is free. So it's very generous for a free tier, but if you pay more, you might get more.
Yeah, exactly. And like I said, you don't even need to put a credit card in, so you don't have to worry, about forgetting that it's running, and then you suddenly have charges. So that's nice. Yeah.
Cool. So one more question here from Jailand. So we have 2 OpenShift clusters. And can we implement Kafka in active mode between the 2 clusters?
I think the key thing, I guess I have to process that question maybe, is so we're managing the Kafka for you. So you're not actually running it on your own cluster, but both clusters can connect to it. But Red Hat itself is managing it on our own infrastructure. So you don't have to provision your own Kafka at all. We're provisioning it. I can't say the word, provisioning it on our own infrastructure. You don't have to worry about the Kafka at all. We keep it active. But I guess I'm maybe not addressing the question properly.
Yeah, maybe it was a question about traditional,
like AMQ streams, maybe, right? Yeah.
About the managed Kafka. Yeah, then maybe we don't know the answer for now.
Yeah, I'm probably not the right person for that one, but we can definitely follow up if we have a channel to do that.
Mm-hmm. And James has a question here. James Dade has, are you guys referencing Knative as a FAS, or is it something else?
Yeah, so yeah, Knative as kind of a function as a service, right? So those functions are running on an OpenShift cluster. They scale to 0. So yeah, it's like a function as a service type scenario, but we're not running them on our own OpenShift for you. You still have to run it on your own OpenShift instance.
Okay. And Vijay is asking, is there any reason why the Kafka icon did not show up on topology view after binding?
Yeah, that was my mistake. As happens with demos, and I've been dealing with so many OpenShift clusters for the last few days. The cluster I was demoing on just now is a different cluster. And I think it was maybe just one tiny version behind, and it doesn't show that icon yet, but it will probably, in a few days or, shortly, I think. The cluster it showed up on, the one where I did show it, is running a slightly newer build. So it's coming soon if it's not in the public ones yet.
Okay, so yeah, so keep your OpenShift instance updated and you get the icon.
Exactly, that's the lesson learned right there.
And I think this is the last one. Juan Cota is asking, is traditional Red Hat AMQ going to be deprecated?
I absolutely do not think so, because we're using, so when we build this service for you, we're using some of those pieces behind the scenes. So it's pretty important to us too. I'm not a product manager, of course, so I can't give an official answer, but I don't think so. I would not expect so.
Yeah, I think people will still be able to use the on-prem version of this product. Yeah, so
we have a lot
you
of
don't have to worry.
customers running OpenShift on premise and Kafka Streams on premise. Like one of the use cases, or sorry, not use cases, one of the references I mentioned previously is a customer doing that, and we have some big customers who we want to keep running it that way.
Awesome. So I don't see any more questions, and we're already on top of the hour. So Evan, thank you very much for this amazing presentation. I hope everybody's excited as I am, because there's a lot of cool stuff happening right now.
It really is.
And I hope to see you again in another DevNation Tech Talk in the future.
Awesome. Thanks for having me, Edson.
Thank you. And if you're watching this, please stay connected, because every week we have new DevNation content, and see you next time.